Hello and welcome to Math with Miss V as we look at what is a sample space. So in this video we will define sample space, look at the three main types we use, discuss when they're best used, and solve a few examples. So we're looking at standard 43 SPB8, represent sample spaces using tree diagrams, lists, and tables to identify the outcomes in a sample space. So what is a sample space? It's a list of all possible outcomes for an event or events. So what are the types? First is a list. All of these end in a list. A sample space is a list, whether you use a table to help you determine that list or a tree diagram is up to you. But ultimately, your sample space is the list that you create. Okay, so a tree diagram is a branching diagram that shows the total number of possible outcomes for compound events. Keyword there, compound. Tree diagrams are not useful for simple events. Tables, we set it up with one event on each side. Again, not useful for simple events, and we'll see why in our first example. Now, tables are good for 2 events, but not 3. Once you introduce a third event, you need a 3D table, and that's just a little complex to draw. And finally, your organized list at the end is a manner of listing all possible outcomes. And it's your answer. This is very good for simple events because there's only one thing that's going on. Let's look at an example. So what is the sample space for spinning a spinner with 5 equal sections that are labeled A, B, C, D, and E? So again, that sample space is all of your possible outcomes. So when dealing with a simple event, it's just a list of the outcomes you could get. So spinning the spinner, I could get the letter A, I could get the letter B, C, D, or E. So that makes this my sample space, just listing out all the possible outcomes. So if I'm dealing with a deck of cards, it would be listing out all 52 different cards in the deck. Okay, our next example is flipping a coin twice. I'm going to show this because a coin only has 2 outcomes. I'm going to show a simple tree diagram and a simple table. Okay, so our simple tree diagram, we would list the outcomes of the first event or the first coin toss. So that would be heads or tails. And then we would draw branches off of each one for our second event. So getting heads or tails with the coin, flipping it a second time. Now my actual sample space would be a list of the outcomes. So I'm going to follow each branch. I could get heads, heads. I could get heads and tails. I could get tails first, heads second. Or I could get 2 tails. And this is my sample space for the tree diagram. Now I could choose to set it up in a table format. So I would have coin 1. Or if the first coin toss has 2 outcomes, heads and tails, I'm going to split that down the middle. And then the second coin again has 2 outcomes, heads and tails. We're going to split it in the other direction. And now you would fill it in. This method, so heads and tails, tails and heads, tails and tails, is very similar to making a Punnett cube or a Punnett square, sorry, in science if you've worked any in genetics. And then again, my actual sample space at the end is a list of all of these possible outcomes. Okay, let's look at our next example. So let's suppose we're flipping a coin and spinning a spinner. Okay, this is one I'm going to only use a tree diagram for because I want to show you 2 different options. So my coin is listed first, so I could list the coin first. And that would be the outcomes of heads and tails. I could then branch off into my 4 outcomes for my spinner. Or I could reverse it. So I did my coin first and my spinner second. I could do my spinner first and list 1, 2, 3, and 4. And there's 2 possible outcomes for my coin, heads and tails. Okay, it's the same thing each way. And then finally, my sample space at the end would be combining these. I'm only going to do 1 sample space. So I'm going to do my spinner. So I could spin a 1 and get a heads. Could spin a 1 and get tails. 2 heads, 2 tails. 3 heads, 3 tails. 4 heads, 4 tails. Now listing the coin first would get the same sample space, just with the information reversed. Let's look at one last example, 2 dice. Okay, this is one I would not use a tree diagram for because a dice has 6 outcomes, and then the second dice each has 6 outcomes. So you're building 6 trees, each with 6 branches, and that can get a little messy. So I have made us a nice table for our first dice with its outcomes 1, 2, 3, 4, 5, 6. And for our second is 1, 2, 3, 4, 5, and 6. And we would fill in, so we would have 1 and 1. The top row fills in across the top. And these columns fill downward. So this would be 2 and 1. So 3 and 1, 4 and 1, 5 and 1, 6 and 1. So 2 and 2, 2 and 3, 2 and 4, 2 and 5, 2 and 6, and then 3 and 2, 4 and 2, 5 and 2, 6 and 2, and so on until we get 6 and 6 down here in the bottom corner. And then to make my actual sample space, I would take the time to list all of the possible outcomes from the table. Although in this case, as long as your work is very neat and organized, as a teacher, I would count this table as a very nice sample space as long as it looked neat and you could use it to answer probability questions. Again, that's up to your teacher. Make sure you check in with them. But thanks for coming out to this Math with Miss Uy video. I hope to see you in the future.